Hello everyone, I'm Bradley Sward, and this is my Day 15 Part 1 solution to Advent of Code 2024. The problem is called Warehouse Woes, and this time I am solving the problem in Python, and I believe for Part 2 I will be solving it in a completely different method, but we'll see when we get there. So the problem is as such. We have a grid. This reminds me a lot of a game that I use to teach gaming called Voxel, Sokoban, many different names to it. Basically, you're just pushing blocks around, and in the game, you're trying to get blocks to specific locations. But it's the same basic idea. Can I push a block? But in the game, you can usually only push one block because you're a human, but you're a robot. So I can push as many blocks as I can because I'm stronger than any human could ever be. And so this is the grid, and this is the initial position of our guy in all the boxes, and then this is all the movements that the robot's going to make. And the question is, when it's all said and done, when all the movements are made, where are all the boxes? And using a math formula of 100 times y plus x for each of the boxes, you will get an answer, or whatever the answer will be. In my case, the answer was 1,486,930. And the code is very straightforward. It's not pretty by any means, gets the job done. I create all the lines in the file, and then this one generates the grid and just the grid. So whenever I hit the empty space here, whenever I go through, and whenever I hit this empty space, well, then I stop. So there's the grid, and then I just create a long string of all these characters. I just kind of concatenate the whole thing together here. And then, so that's this whole part there. And so just to say the final part here where it gets me to the solution is just exactly that. If I want to go left, if I want to go right, if I want to go up or down, try to go there. If there's a dot, well, it's an empty space, so just move there. And if it's a 0, meaning a block, well, let's check to see how many boxes are actually there in the row and to continue on. And in this case, I continue on until I hit something that is not a 0, or basically not an O. And when I fall out of this, well, it's either going to be a dot, because it's going to be an empty space, so I can push the blocks that way, or it's going to be the asterisk, the octothorpe there, that tells me, no, I can't push any of the blocks. So if it is a dot, I just basically move everything around. I move my position, and I move all the boxes over in the direction that we're trying to move it, and we just do that over and over and over again. And it's not pretty. And then at the end, I just do the math to figure out, find all the O's. Oops, I'm sorry, I have a breakpoint there. And then pretty much instantaneously, I get the answer of the 1,486,000 that I'm looking for. So that is how I solved it. Again, not the prettiest, not the coolest. I'm sure you guys have some ingenious solutions out there in the world. But for part 2, I plan on doing something a little more visualization heavy here. So we'll see what we can do. Thanks for watching the video. Please comment if you have anything to add. I'd love to learn how to do it better, just like everyone else. But thanks again for watching, and I hope to have part 2 done pretty soon.